Hey everyone, I just wanted to make a quick video reminding you how to graph sine, cosine, and tangent. I kind of wanted to give you my process using just a circle, the unit circle, or just the idea of a circle. So just a reminder to make this video super useful for you. Pause it at any point, rewind it, fast forward it, and my favorite feature, change the playback speed. If I'm talking too slowly, play this on 1.5, 1.75. If you're feeling adventurous, play it on 2 times the speed. If I'm talking too fast for you, slow it down or pause it as you go. But let's remember how to graph sine and cosine. So just a quick reminder that this is all based off the unit circle. The unit circle being a circle centered at the origin. That's why I marked 0, 0 right here. Centered at the origin, radius 1. So I'm just going to label all the coordinates around this. If this is labeled, or sorry, if this is our radius of 1, this is actually 1, 0. If this is still a radius of 1, this is 0, 1. Again, still a radius of 1 makes this now negative 1, 0. And the last one on our circle, 0, negative 1. And this is going to be helpful because we do know this information up here. If we think of our coordinates x, y, in the trig context, we can think of it as cosine, sine. So each of these coordinates we're looking at, the x coordinate is cosine. So if I'm going around the circle, our cosines are 1, 0, negative 1, 0, back around to 1. And if I'm looking at sines going around the circle, our sines are 0, 1, 0, negative 1, back to 0. So I'm going to use that in graphing, and I'm going to start by graphing sine. So here's where I'm going to graph our sine curve. And I really only look at the 4 quadrants, and I've broken those 4 quadrants down in radians. When we're looking at a 0-degree rotation, that's right here. So our sine value starts right here at 0. Let's rotate 90 degrees, or in radians, that's pi over 2. And that brings us to this point right up here. And that means our sine is 1. Okay, rotate another 90 degrees, or another pi over 2. That brings us to pi. Our sine is back to 0. Rotate another 90 degrees, or in radians, pi over 2. That brings us down here. Our sine is negative 1. And then right back to where we started, 0. And we connect that in a nice smooth curve. If you need to, if you need to plot some points in between, you can, but we really choose just these 5 points, every quadrant of the circle, starting at 0 and stopping back at 2 pi, because that shows us the full shape of the sine curve. And everything would just repeat from there. So if I could keep this going, every pi over 2 or every 90 degrees, I would come back to those same 4 points and repeat the pattern. Okay, let's check out cosine. Cosine is the same thing, only you're going to notice we're using the x value. So starting with this x value right here, my x value is 1. So here we're going to set up our cosine curve right here. Okay, let's do a 90-degree rotation, or pi over 2. We're right here. So now my cosine value is 0. Let's do a 90-degree rotation, or pi over 2. And now I'm at negative 1. A 90-degree rotation, or now 3 pi over 2, 270 degrees total, brings me back to 0. Again, I'm looking at the x coordinates this time. And then right back to where I started at 1. So connect that as a smooth curve. Remember, this is a circle, and we're modeling circular motion. So they should be nice, round, smooth curves, not straight lines, because this is not, this circle right here is not a straight line. It is round circular motion. So for sine and cosine, you're going to see different transformations. One of the main transformations is, well, what if this radius wasn't in fact 1? What if instead the radius was 2? Well, then this point would change to 2, this point would change to 2, this point would change to negative 2, and this would change to negative 2, which would just really simply extend this up to 2 here, this down to 2 here, this to 2 here, 2 here. Nothing else would change. Everything else stays the same. It just extends up to 2 and down to 2 now. So this would be 2 sine x. Okay, so another transformation you might see is, what if we shifted the whole thing down? What if this was now cosine x minus 1? What if we dropped the whole entire unit circle down? Well, that's just like changing our midline to being right here. But our curve still completes the same circular motion, just around a new center point. So around that new center point, we're still 1 above, 0, 1 below, 0, 1 above, and the same exact curve. And again, that would repeat back to 0, 1 below, back to 0, 1 above. So those are how you would do some simple transformations. In this task, you'll see transformations that are also X shifts. I want you guys to test those out. Maybe watch a video if you need to, but definitely come to office hours. I would love to try out some of those X shifts with you. But let's check out tangent now. Tangent is the one thing that, I don't want to say it's new, but it's just slightly different. It operates a little bit differently. So I'm going to kind of erase what I've got going on here. We're still thinking about the unit circle, and we're still going to think about those points. So I'm going to relabel them. This would be 1, 0. Here we have 0, 1. And again, that just means over 0, up 1. I'm just stating the coordinates of these points. This is how I pretty much memorize. You guys know I don't like the word memorize, but this is how I remember all of these graphs. If I can remember these 4 coordinates of the circle, everything else I need comes from those. So tangent, if we remember, tangent is sine divided by cosine. So at each of these coordinates, I'm actually going to take my y value and divide it by my x value. So let's start here at 0. Let's start at 0. So at 0 right here, our y value is 0 divided by our x value, 1. Well, that's just 0. Cool. Let's go to the next one. Our y value of 1 divided by our x value of 0. This is undefined. Every time we've come across an undefined point, that's an asymptote. So I am going to draw in an asymptote. Let's keep going around the circle. We come back to here, and I have my y value of 0 divided by my x value of -1. Cool, that's still 0. And let's come to our last point right here. Here's our y value of -1 divided by our x value of 0. Again, that's undefined. And here we're actually able to establish our pattern. When we come back around to 2 pi, we're back at 0. When we come back around to pi over 2 later, or 5 pi over 2, we have another asymptote. So now we just have to decide, well, what actually happens in between here? What happens in between here? So I like to just take this one point right here, 45 degrees or pi over 4. And I love this point. It's really easy because it's radical 2 over 2 as the cosine and radical 2 over 2 as the sine. So just thinking through, what is y divided by x? It's 1. And then if I look at this same exact coordinate in this quadrant, I know it's still radical 2 over 2 and radical 2 over 2, but now my cosine is going in the negative direction, so that makes my tangent -1. And then let's think about this one right here. It is still radical 2 over 2, comma radical 2 over 2, but my cosine is negative and my sine is negative both. So my tangent, negative divided by a negative, comes back to +1. And last, we can verify it when I'm checking out this point right here. Again, I still have radical 2 over 2 and radical 2 over 2. My cosine, or my x-coordinate, is now positive, but my sine is still negative. So I have another negative tangent. And then the pattern just continues. when we connect those dots to follow the asymptotes, we find these kind of cubic functions, sort of, kind of, that are all kind of separated by the asymptotes. Now, if you notice, there are a few things that are strikingly different. My curve repeats every pi. The ones above repeat every 2 pi. So my full period is 2 pi for sine and cosine, but it is just pi for tangent, meaning I'm going to see this kind of cubic function repeat every pi. Now, let's kind of test this out. This is our tangent. Well, what if I wanted to change the amplitude? That amplitude point shows up at our pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So this would extend up to 2 if we decided to make it 2 times tangent. And this would extend down to -2. Oops. Sorry about that, guys. This would extend down to -2. This would extend up to +2, down to -2, up to +2. So we would just see a slightly steeper form of those kind of cubic shaped functions. So this is how I use my unit circle to, not even my unit circle, this is how really I just use a basic circle centered at the origin. Just a basic circle centered at the origin to graph sine, cosine, and tangent. Test this out. Maybe find a method that works for you. Try out without a calculator. That's what I want you guys to focus on. Try the questions out on today's task. It's 6.2 through 3. You'll see graphing sine, graphing cosine, and graphing tangent. Don't forget that we have office hours twice this week. We're following a schedule, so your office hours are either on Tuesday, Thursday, or Wednesday, Friday. Come with questions. I'll see you then.